Okay, so this is the first question that we have over here. It says find the equation of the plane containing the point that is perpendicular to the line of intersection of two planes. Okay, so we have this equation number 1 and equation number 2 over here. So this is the normal vector given to us to the first plane and the normal vector given to us for the second plane. Okay, and we need to find the directional vector in order to find the the plane that is perpendicular to the intersection of these two planes. Okay, so let's go ahead and do that. So for this we have these two, so we're going to cross product these two normal vectors. Okay, so if we do that, this is how we do it: I, J, K. And since you're cross producting n1 cross n2, so make sure to write n1 first. You cannot write n2 first, otherwise you'll get a wrong answer. Okay, so n1 first. Okay, so we're taking only the numbers over here. Okay, so ignore the variables for now. -1, 1, -8, that's 3, -1, and 2. Alright, once we have this, it's really simple to take the cross product. So what you're going to do first, you're going to cross out the I hat, the column, and the row. Okay, so once you cross this out, you're just going to multiply in this direction, like top to bottom, and then negative bottom to top. Okay, so just like that, crossing out the ith row, multiplying this, negative this. So if you multiply this times this, that's 2, and this is 8. Okay, so you do 2, and then negative, that's a positive, but it's negative multiplied by 8, so that's gonna be 8 I hat. Okay, similarly you do the rest. So you're going to cross out the j row and column. Okay, so we're gonna get 2 and 24. And yeah, it's negative j always. Okay, so this is positive, this is negative, but this is positive. Okay, so always remember this is negative j. 2 plus 24 plus k hat, and then for the k hat you do the same thing, crossing out this times this times this, which is gonna give you okay. Now if you do the math, so then this gives you -6 I hat, and this negative multiplies the inside, so then it becomes -2 j hat and -2 k hat. Okay, so this is your normal vector now. And to know the equation of the plane containing the point, so you're going to take this normal vector, okay, and plug in into the equation of the plane. So the equation of the plane is something like x minus x0, and here comes our vector, the components of the vector that you have, and then you're gonna do the same thing, and then here you're gonna have 22, and then here it's gonna be y minus y0, and -2 z minus z0 equals to 0. And this x0, y0, and z0, it's nothing but simply the point that is already given to us in the question. So 1, 7, -1. So our point is 1, 7, -1. So this is x, this is y, this is z. So x0 replaces 1. y0 is replaced with 7. And -1, negative, that makes a positive. So then here we have 1. And you can leave your answer like this. This is the equation of the plane that we were asked to find. Or you can multiply this, and your final result turns out to be 3x 11y plus z is equals to 79. So like I said before, you can leave your answer to be like this, or if you want to simplify it a little bit, so this is your final answer.